Okay, last page. This is so funny because I think I've done number 8 like 3 times. This is like the third number 8. Okay, so solve the quadratic equation by factoring. Well, in order to solve by factoring, you have to set it equal to 0 first. So the first thing you have to do is move the 24 over. X squared plus 10x minus 24 equals 0. Now we factor. Factors of negative 24 that add up to 10 are 12 and negative 2. Now, this is a standard problem. There's a 1 right here. So I can just take these and go and put them right here. Right? I don't need to do the magic x because there's a 1 right here. X plus 12, x minus 2 equals 0. Now it's time for mini equations. Solve them. X equals negative 12, x equals 2, and you can put those in a solution set. Next, I'm going to solve this one by getting this side equal to 0 as well. Notice that I'm like matching it up with its like term. I'm not going to put negative 15 over here because that's not its like term. 5x squared minus 23x. 5 minus 15 is negative 10 equals 0. Now I'll set up my x. It's a advanced problem. 5 times negative 10 is negative 50 and negative 23. Factors of negative 50 that add up to negative 23 are negative 25 and 2. Now because it's advanced, I have to divide by 5. This is simplest form. This one I need to make negative 5 over 1. Okay, so now I can take these and make them into the factors. 1x minus 5. So I'll write x minus 5. 5x plus 2. Oops, 5x plus 2. Mini equations. Add 5 to both sides. X is 5. Subtract 2. 5x equals negative 2. Divide by 5. My solutions are 5 and negative 2/5. Another one to solve by factoring. Now for this one I have 2 terms to move. I have to move the 2x squared, so I'll subtract it and I'm going to line it up with its like term over there, and I have to subtract 7, so I'm going to line it up with a number. This side becomes 0, this side becomes 9x squared minus 25. Now here we go again with these 2 terms. Whenever I see 2 terms, I'm very skeptical. This has got to most likely going to be a difference of squares, and it is. That's a perfect square, and that's a perfect square. How do you make 9x? It has to be 3x times 3x. How do you make 25? 5 times 5. One's positive, one's negative. Make 2 mini equations. Subtract 5. 3x equals negative 5. X equals negative 5/3. Add 5, so 3x equals 5. X equals 5/3. And there's my 2 solutions, negative 5/3 and 5/3. Okay, again, I got 2 things that need to be moved on this one as well. 6x squared. And got to add 25 to both sides. Now 25 is weird because it doesn't have a like term over here. I'm just going to put it there for now, but I can't combine it with the 10x because those are not like terms. 7x squared minus 6x squared is x squared. Minus 10x plus 25 equals 0. This is factorable. Factors of 25 that add up to negative 10. Negative 5 and negative 5. It's a standard problem because that's a 1. So I can just take this. I don't need magic x. Just take that and bring it over. X minus 5, x minus 5. Now you could write 2 mini equations if you want. They're the same mini equation. You get the same answer. X is 5 for both. So this one actually only has 1 solution, and that's 5. Okay, here we have a factored form. So this is the factored form of a function. And we're trying to get it to standard form. Now these were just the opposite. We started in standard and we went to factored. So the way that you do this is by making your x, right? The way that you go from factored to standard is by foiling or doing your box method. So I'll do x times x is x squared plus 2x minus 5x minus 10. And then combine like terms. Now notice this did not say solve it. It just said write it in standard form. This is standard form right here. If you don't like foiling, right, you'll use your box to do the multiplication, and you'll set it up x minus 5, x plus 2, and then these are your like terms. X squared minus 3x minus 10. Okay, last one is about the transformation rules. Again, we're like picking things apart here. When I see plus 3 here, that means it goes not to the positive side, it means it goes left 3. And I'll also write that down here. Left 3 units. Minus 7 means down 7. That one sort of follows what you would expect. It's minus, so it's down 7 units. And this one, this is the one on the first page. It was called, what did they call it? A stretch. We were calling it narrow. That's fine. Stretch would be fine. Narrow would be fine. It's not really a change in slope, but I'm just going to write it becomes more narrow. And we'll look exactly how that happens over here. Okay, so I'm going to go left 3 and down 7. So that puts the vertex right here. And then when I go to put the other points on, I know that it opens up because this is a positive number here, this 2. But the way that I put the other points on is not to go over 1, up 1. Because there's a 2 here, I have to double all the y values. So over 1 and up 2 and put a point. And then come back to your vertex. Go over 2. Now normally we would go up 4, but instead we go up 8 and put a point. And then over 3, don't go up 9, right? Go up double that. Go up 18. Oh dear. That's 15. 16, somewhere up here. Okay? So, and then I'll sort of fill in the partners on the other side. I end up with a skinnier graph. Some would say it's been stretched out. Some would say it's narrower. But that's the transformation that comes from the 2. Okay?